Hi, this is Kumaresh. I'm from Mechatronics department. My presentation is about on engineering mechanics and their introductions. So first of all, in engineering mechanics, we can know about the force. Force, we already know there is the action of one body on the other. It may be push or pull. On that, we consider the applications. We can consider two factors. One is the direction and one is the magnitude. For magnitude, we can find the resultant force. When the number of forces acting on a body, we can consider the resultant force. So that will be called as magnitude. The directions which can use it as the angle. That means the force angle. So this can be found by using the resultant force instead of theta. So next one is what is the need of knowing mechanics? Mechanics, it always deals with the forces. Completely it deals with the forces. For example, we'll consider a moving car. We consider the following factors like weight and reaction force and driving force, friction and air resistance. These are all about the forces we can consider for the mechanics. So it can be classified as mechanics of rigid bodies and mechanics of deformable bodies and mechanics of fluids. In mechanics of rigid bodies, it can be further classified as statics and dynamics. And dynamics, it can further classified as kinematics and kinetics. What is meant by rigid body mechanics? Uh, for same as while considering the moving car, when we studying the external effect of forces on a body such as velocity, acceleration and displacement, it is called as rigid body mechanics. For the same, we can consider the internal effect of forces on the body such as stresses, that means internal resistance and change in shape. We can call it as deformal body mechanics. So next one is what is statics. Statics, it always deals with the forces when it is at rest positions, and dynamics, it deals with the forces when in a moving conditions. In statics, we can example for truss bridge, that means steel structure bridges. Okay, then dynamics, the example is IC engines. So next one is the what is mean by rigid body mechanics. Rigid body mechanics means there is a negligible deformation. That means there is no deformations under the action of forces. Assuming 100% strength in the materials, large number of particles, there will be in a fixed position with each other. That is called as the rigid body mechanics. When actual structures and machines are never rigid because um, there will be very small amount of forces, sorry, small amount of deformations will be happen in that, so it does not affect the equilibrium conditions. So that only we call it that is rigid body. On a naked eye we didn't see about the deformations, but when applying the external load there will be the deformation, but it will be not visible to the naked eye. Then particle mechanics, this same as the rigid mechanics, but here we can consider the size. That means there will be the very small amount of matters which is assumed as the point in space. For example, studying the orbital motions of Earth. Then next topic is the types of forces. What are the types of forces in mechanics? Concurrent, collinear, and non-concurrent, and concurrent non-coplanar. That before that, coplanar forces means there will be the number of forces which will be acting on a single plane, that is called as the coplanar force. For the concurrent coplanar force means there will be the each and every forces will be passing through the one point, that means the origin, that is called as the concurrent coplanar forces. Then collinear forces means there will be the number of forces which will be acting in the same line of actions, is called the collinear forces. The non-concurrent coplanar means there will be the number of forces which will be acted randomly in a single plane. It is called as a non-concurrent coplanar or parallel forces. Then next one is the concurrent non-coplanar means there will be the force which will be acting on this several planes, but it can pass through the same point. That is called as a concurrent non-coplanar. Then what is the components of force? When in a 2D axis, we can consider the forces. It will be called as the plane forces. It's the same. We can consider as a 3D, three-dimensional. It will be called as space force. The next one is the couple. Couple means there is a two equal and opposite forces which will be acting at the same distance, some distance from forming the couple. For example, when we tighten the wheel by using the screwdrivers, there will be we can applying the equal and opposite forces for some distance. That time it creates the couple forces. During the rotational effect, there will be the change in distance, and in this diagram it will clearly shows. For the first one shows that there is a 30 Newton couple force which will be acting at the distance of 0.4 meter. The second one is the 40 Newton force which will be acting as a couple at a distance of 0.3 meter. So this only clearly know about the rotational effect will be change the distance. Next one is the free body diagram. Free body diagram means we can isolate the body from the structure of machinery or some other factors, external body structures, which shows the forces and reaction forces acting on it. We can eliminate the external factors or structures, and we can draw while all the forces which will be acting on it and the reaction forces acting on it. That is called as free body diagram. And these are some of the examples of free body diagram. So we can just eliminate the external structures and we consider the forces acting on it, like reaction forces and some other forces or weight. That is the free body diagram. Thanks for watching this presentation.